Last time we have seen the concept of VCM, vertical circular motion. We have seen that in VCM, velocity of the body changes from point to point. So in VCM, velocity of the body is not constant, not uniform, and we have seen that VCM is not UCM. Then we have seen the tension at one point, topmost point, highest point. In examination, question is normally asked, obtain expression for tension at highest point in VCM. Or question is asked, obtain expression for tension at bottom point in VCM. So today we will see tension at bottom point, that means point B. So when the body rotates in vertical circular motion, when the body comes here at point B, there is some tension in the string. Let us see how to find out expression for tension when the body is at point B. So the forces acting on the body at this typical position, at this typical point B, are number one, its weight W vertically in downward direction. We know that every body is under action of gravitational force. So each body has some weight which is directed vertically in downward direction. So one force, weight is equal to W is equal to M into G. Direction important, direction exactly in downward direction. Second, tension T. Along the string there exists a force, a tension. Therefore, the body is bound to this string. Suppose tension is not there, string is not there, then body has a tendency to move in downward direction. As the body is not moving in downward direction, we can say that this typical force is balanced by effect of this force is removed by this typical force. So I can say that there exists a force tension in vertically upward direction along the string. So two forces are there, weight W downward direction, second tension T in upward direction. So both are exactly opposite to each other. So one force upward direction, second force downward direction. So we can say that there exists a resultant force, a total force. So this is upward by assumption, this is taken as a positive, and this moving downward direction, it is taken as negative. So total force or resultant force will be F is equal to T positive upward direction minus mg. Why minus sign? Because exactly opposite direction, downward direction. So we get total force F is equal to T minus mg. Here, as the body is moving in circular path, even though two forces are acting on the body is performing a vertical circular motion, and we have seen that whenever body performs a circular motion or moves along a curved path, definitely a centripetal force is acting. So in this case, the resultant of these two forces is nothing but centripetal force. So centripetal force is provided by the resultant force. In other words, I can say that this force is responsible for circular motion. So I can say that centripetal force is equal to resultant force F. So by definition, by concept, by standard formula, centripetal force CPF is given by the formula mv square upon r, where m indicates mass of the body, v indicates velocity of the body. So body is moving with some velocity. So this indicates velocity of the body, this m, mass of the particle, then g, gravitational acceleration, and r indicates the radius, that means distance from center point of the circle to the exact position of the particle. So this typical distance is nothing but r. So we get mv square upon r is equal to T minus mg. So this minus term we can transfer on the other side, it becomes positive. So we get T is equal to mv square upon r plus mg. So this expression gives us tension at bottom point, that means lowest point in VCM. In examination, question can be asked, obtain expression for tension at lowest point or bottom point in VCM. So this answer is expected in examination. Let us go further. Next point of this chapter, the concept of velocity V1 at highest point in VCM. So we require to find the expression for velocity at topmost point. So again we require a diagram. So suppose this is vertical circular motion. Suppose this point is point A. This dot indicates point A. So this body is moving with a typical velocity v1, and we have seen that in previous lecture, tension acting at this typical point, highest point in VCM, is given by T is equal to mv square upon r minus mg. We should know this formula, otherwise difficult to find out expression for velocity. So certain terms you should know properly. Then, now just imagine that the velocity of the body, this speed of the body, velocity of the body is decreased continuously. Just imagine that the velocity go on decreasing. At a typical stage, when velocity becomes equal to a critical velocity v1, at that time tension in the string becomes zero. And suppose further velocity is less than this critical velocity v1, then tension does not exist. The string becomes slack. So there is no vertical circular motion. So what is the condition for VCM? We require typical value, minimum value, critical value, V is equal to VC, V is equal to V1. V1 is called as critical velocity. Then and then there is a performance of vertical circular motion. Let us see how to find value of this V1. We have seen the condition when V is equal to V1, that means critical velocity. At that time tension becomes zero. So this value put in equation 1, we get equation 1 is known to us, T is equal to mv square upon r minus mg. So we get tension, in place of tension we write 0 is equal to m, in place of v we write v1 square upon r minus m into g. Our aim is to find out speed, velocity v1. So this term on one side and this term on the other side. So we get mv1 square upon r is equal to m into g. Clearly the common terms from left hand side and right hand side of the equation can be cancelled. So we get v1 square is equal to r into g. We want to find out v1. So for that we take roots of both sides. So taking roots, same operations on both sides of the equation are allowed. So we get under root v1 square is equal to under root r into g. So perfect square, v1 square perfect square will be outside. So v1 is equal to under root r g. So what you observe here, this velocity at the topmost point depends upon only two factors. Number 1 r, radius, and number 2 g, that means gravitational acceleration. So we get critical velocity is equal to v1 is equal to under root r into g. So in examination question can be asked, obtain expression for critical velocity, velocity at topmost point in VCM. All of you understood? Let us go further. Normally, again a question can be asked, obtain expression for energy at highest point. That means point A. Again we require a diagram. So topmost point is A point. So body is moving like this. So V1. So I can say that this is center of the circle. The distance of this point with respect to center of the circle is R. So total energy is the combination of kinetic energy plus potential energy. So we get total energy TE is equal to KE plus PE. So we get TE, E is equal to 1/2 mv square plus potential energy mgh. What do you observe here? We require h. M is constant, V1 is known to us. We have found out value of V1 is equal to R into G, under root R of R into G. So we get E is equal to 1/2 M under root R into G square plus M into G. Now H. H means height. So we require starting point to measure height. We imagine a straight line which is passing through the bottom point, lowest point, and from this we measure distance, measure height. So with respect to bottom point, this typical distance is nothing but 2r. This is r plus r. So in place of h we can write 2r. So we get E is equal to 1/2 M R into G. Square is gone, roots, because of square, root is gone, plus 2 times mg into r. So there are some examples based upon this formula. So we can solve this example which is based upon this formula. Let us go further. Normally question is asked sometimes velocity at bottom point. We obtain expression for velocity at highest point. Let us see how to find velocity at bottom point. Again we require a diagram. There are 2 points, point A and this is point B. So point B is lowest point, bottom point A is highest point. So here velocity is suppose V2 and suppose here velocity is V1 and we obtain expression for V1 is equal to under root R into G. So to find out velocity at this typical point, we require concept of conservation of energy. Principle of conservation of energy. Principle of conservation of energy. What is the principle? Energy neither created nor destroyed. It can be transferred from one point to the other point. So we can say that energy at every point of this typical vertical circular motion is constant. It is not vanished. Or we can say that total energy at point B is equal to total energy at point A. So energy at this typical point and energy at this typical point is equal, same. So EB nothing but combination of kinetic energy plus potential energy at point B is equal to again kinetic energy plus potential energy at point A. Kinetic energy is given by the formula 1/2 mv square plus potential energy standard formula mgh. So here with respect to point B is equal to again formula 1/2 mv square plus mgh with respect to point A. So here we can say that V for point B, we assume that for point B V is V2. So in place of this we can write 1/2 mv2 square plus mgh, m as it is, g as it is, h means height of this point B with respect to starting point. So for point B we assume that starting point is here. So we can say that h is equal to 0 because we assume that starting point is at point B, lowest point. So starting point of origin with respect to B point is 0 is equal to 1/2 mv1 square plus mgh. Now for point A, h is this typical height. So r plus r that means mg into 2r. So we get 1/2 mv2 square is equal to plus 0. Why 0? mg into 0 is 0 plus 1/2 equal to 1/2 m. In place of v1 we write r into g. Just now we obtain expression for v1 plus 2 times mgr. Here we can say that v1 is equal to under root gr. So we get 1/2 mv2 square is equal to 1/2 m r into g. Square is because of square root is gone plus 2 times mgr. The common terms m get cancelled. So v2 square upon 2 is equal to rg upon 2 plus 2g into r. We can say that v2 square is equal to 2 in a bracket rg upon 2 plus 2gr. Transfer this on this side. So we get v2 square is equal to r into g. This 2 to get cancelled plus 4gr. So we get v2 square is equal to this 4 plus 1 common term gr. So we get v2 square is equal to 5gr. We want to find out square root. So taking roots of both sides, v2 square is equal to under root 5gr. So we get v2 is equal to under root 5gr. This is our required answer. So we get velocity at bottom point. Exam question can be asked obtain expression for velocity at bottom. Now we stop here. Next time we will see remaining part of this chapter. Thanks.